So, today we'll discuss about a few basic law of optics. So first, if any optical signal propagating through particular medium, then what will be the how you will calculate the refractive index of that material. So this can be calculated by using this formula n is equal to c by v. Here c is the velocity of light in vacuum and the v is the velocity of light in a medium. And the ratio of C by V gives the refractive index. So this is here mu r is the relative magnetic permeability and this is the relative electric permittivity. So if the medium is non-magnetic media, then the value of mu r is 1, then the refractive index will be given by epsilon r. This is the relative electric permittivity. So basically the refractive index is a fundamental optical parameter of any material. And this is very important parameter when we are discussing about the optical fiber. Now next, law of reflection and refraction. You already have some concept of reflection and refraction, but let's quick review over these law. So here this is the material boundary. This is material medium 1 and this is medium 1 and this is medium 2. And the refractive index of this medium is n2 and refractive index of this medium is n1. So consider a light ray passing through the consider this light ray. This is incident at this material boundary. So some of the light rays get reflected back in this medium only. This is so light is incident and get reflected back to this medium only, and this is known as a reflected ray. Some of the light enters in the second medium. So this is the second medium. So light incident at the medium and enter into the second medium. So here you can see when this light incident here and enter in second medium, it is little bit bent. There is a bend in this refracted ray. So the what is the reason behind this bending? This bending of ray is due to change in the refractive index in these two medium. So how will you calculate the refractive index? This we have seen in earlier slide. So on the basis of this discussion, here we define two law, reflection law and Snell law of refractions. Reflection law says that angle of incidence is equal to angle of reflection, and Snell law of refraction n1 sine phi 1, this is incidence angle, and n2 sine phi 2, this is refraction angle. Angle of refraction. Phi 2 is an angle of refraction. So this is the Snell law of refraction. And this I have referred from the Optical Fiber Communication third edition book by Keyser, Tata McGraw Hill publication. So you can go through this book and you can read about reflection and reflection in more detail. Uh, Now next, total internal reflection. So till now we have seen reflection and refraction. Now what is total internal reflection? Here you can see three different diagram. Here in first diagram the incident light get incident at the boundary, material boundary, and get in, and enter into the second medium. So here the refractive index of this medium is N1 and refractive index of this medium is N2, and N1 is greater than the N2. The refractive index of medium 1 is greater as compared to refractive index of another medium. So light incident and get refracted. And in next case, light incident at angle phi c, and the refracted light make angle of 90 degree with this normal line. Or here we can say angle of refraction phi 2 is a 90 degree. So here the angle at which light is incident is known as the critical angle. And in the third case, when the angle of incidence is greater than the critical angle, then the light is reflected back into the first medium only. So this is the total internal reflection. So when there will be total internal reflection when the angle of incidence is greater than the critical angle. When it is equal to the critical angle, then phi 2 will be 90 degree. So for the total internal reflection, this condition must be achieved. That is phi 1 must be greater than the phi c. And how you will calculate the value of critical angle? Sin phi c is equal to n2 by n1. Here n2 is a N2 and N1 both are the refractive index of medium 2 and the medium 1. So this is all about the total internal reflection. So in this we have covered law of refraction, total internal reflection, what is the meaning of critical angle and its importance, and how do you calculate the refractive index of any material.